Hello students, this is Dr. Ben. I'd like to work another problem out of Chapter 6 that has to do with the concept of work and also the concept of kinetic energy. So here we have a situation that is a process that's occurring basically in the horizontal direction. And it involves an object that's being pushed by a couple people, and we're given some information about the motion, and we're asked to find something about the force that acts. So let's real quickly make a list of what we know before we get too far along. So we have two people that push this bag. We're told the mass of the bag is 12 kilograms on a frictionless surface. Constant horizontal force. So the force is constant. And the distance that's traveled is 8 meters. Starts from rest. The original velocity is equal to 0. The final velocity is equal to 0.4 meters per second. And we're asked to find the value of the force, and we'll call that the pushing force. Okay, so let's draw a pictorial representation just to get an idea of the geometry. So we'll let the box move along a horizontal direction, and so here's going to be the position of it at the beginning of the experiment, and here's the position at the end. And so the distance that it travels is the distance d. It has a mass of m, and it starts out with initial velocity of 0. And the final velocity is to the right, so there's an acceleration that has to point to the right. And we're asked to find the value of the pushing force. There we go, F sub P, that's required in order to make this happen. Okay, so we want to use the work kinetic energy theorem to solve this. So we're going to say that the work that's done by all the forces is going to be equal to the change in the kinetic energy. And if we draw a force diagram for this box, there are 3 different forces that act. So there would be the weight, there would be the normal force, and there would be this pushing force. But because the normal force and the weight force are perpendicular to the motion, they do no work. So we only need to find the work that's done by the pushing force. So the work done by all the forces will actually be equal to the work done by the pushing force, and then that will be equal to the change in the kinetic energy. Alright, so let's move the paper up a little bit and have some more room. So the work done by the pushing force, using the definition, will be the value of the force, F sub P, multiplied by the displacement, so that's the symbol d in my picture, multiplied by the cosine of the angle between those two vectors, which is 0 degrees in this case. And that's going to be equal to the final kinetic energy minus the original kinetic energy, and the original kinetic energy is equal to 0, and the cosine of 0 is equal to 1. So we've already got some simplification. So we have the pushing force, F sub P, multiplied by the distance, multiplied by 1, is equal to the final value of the kinetic energy, which is 1/2 mv final squared. So to solve for our unknown, which is the pushing force, we just have to do a step of algebra and cross multiply, so the pushing force will equal mv final squared divided by 2 times d. Alright, so using the numbers from our problem, we would have 12 times 0.4 squared divided by 2, and then divided by the distance, which is 8.0 meters. Alright, so I'll get my calculator out and work that. So I'll take 0.4 squared times 12 divided by 2 divided by 8, and so that equals 0.12, 0.12, and that would have units of newtons because we found the value of a force. Alright, so that's a pretty small force, but it's related to the fact that the final speed of this box is not that large. So this is an example of using the work energy theorem in order to relate the forces and the motion.